Okay, we're making the transition from messing around with quadratics and looking at their graphs and trying to find their vertex and changing them from one form to another. And we're going to see several different ways of solving quadratic equations, kind of the coup de grace right here, the last one, using the quadratic formula. But we're going to basically skip this one. I want to show you what it means, though, when you solve a quadratic equation by graphing. So here's a quadratic equation listed right here. And here's the graph of it. And again, this graph is all of the points that make that equation true. If you put in the x-coordinate and calculate it, you get the y-coordinate. Well, we could solve this thing. For instance, if I wanted to find out what is x when this is 0, I can just move along the graph until I get to where y is 0. And it looks like it's, pretty close to right there. Negative 0.5 for x gets you 0. So basically you've solved that. And then over here you can see that if you put a 3 in there, you also get 0. So we've solved that quadratic, and we're not going to mess around with that a lot with that. I just wanted you to see it. Okay? So what we're going to be looking at is solving using a technique called taking square roots. And it turns out you've done this before. Okay? Way back when you did pre-algebra or algebra, you learned about the Pythagorean theorem, and you learned that if you take the two short sides, a and 12, and you square both of them, and you add them together, you get the square of the long side. The old a squared plus b squared equals c squared. Okay? When you solved this, because there's a squared in here, it's a quadratic equation. So when you did this, you had a squared plus 144 is 169. Then you subtracted 144 from each side, and you got 25. Okay? And you said, okay, look, a is the number where if you square it, you get, you get 5. Okay? So then you found out the answer to this. You got 5. So you solved a quadratic equation. Okay? There's a couple of things that I want you to be aware of. First, here's a heads up here. Were you asked to find an exact solution or a rounded answer? Well, here's what I mean by that. We got exactly 5 on this one, so that's an exact answer. But if you'd had the, say, numbers here that were, let me change this to, I don't know, 18 and 21, okay, then we would have said, look, a squared plus 18 squared is 21 squared. When we solve this, let's see, 18 squared, that is, that's 324. Okay. 21 squared is 441. Okay. Then you would have subtracted 324 from each side, so let me do that. You get 117. Well, there isn't a number that squares exactly to get 117. So what you did is grab a calculator and typed in square root 117 and got your answer of 10.81665383, and then more digits if you've got a big calculator. But we just said rounded off to the, say, the nearest tenth. So we got 10.8. Well, if they had said, please give your answer exactly, then you couldn't do that, because even if you gave 8 digits, there's still a ninth digit. Or if you gave 15 digits, there's still a 16th digit. So you still don't have it exact. So what you would do is you would write the square root of 117 instead of writing out decimals. And people go, well, why would you do that? Well, sometimes when you're doing some kind of calculation like this, it's part of a much larger problem. And you might get your answer for this and then send that answer to somebody else who's working on some other part of a bigger problem. And they might want to have their answer really, really accurate, okay, or they might want to decide how accurate they need the answer. So if you just leave your answer as square root 117 instead of trying to round it off to some decimal number, then you've got a more exact answer. Okay, so that's one thing to watch out for. The other thing I want you to watch out for is this. Oops, let me just find an empty page here. When you're asked, hey, would you please solve this? Okay, most people say, yeah, no problem, x equals 5. And I say, that's exactly right. And what's the other answer? And I get kind of blank stares. What do you mean the other answer? Well, there's another number that squares to get 25. Okay, I agree. 5 squares when you square 5, you get 25. But also, when you square negative 5, you get 25. Okay, so if I write this, negative 5 squared, that's 25. A negative times a negative is a positive. Okay, so oftentimes the way people write that is this: x equals plus or minus 5. That's what that means. Let me write plus or minus. That's what that sign means. Okay, so that means both positive and negative 5 work. Okay, so let me clear that. So if I asked you, please tell me the solution to this, x squared equals 51. Well, there's no whole number that squares to get 51. Okay, so what you're going to do is simply write x equals the square root of 51. But you're going to recognize, because there are two numbers that square together to get 51, we'll write plus or minus out front. So that would be a complete answer right there. Okay, so let's look at some of these and get answers. So here's a real simple one. To unsquare both sides, you'll square root. Okay, you'll get 9. Don't forget, they're positive and negative. Okay, so 9 is a whole number. It squares to get 81, so you got an exact answer there. On this one, we're going to start by subtracting 14 from each side. You get g squared equals 24. And then, is there a number that squares to get 24? Well, not a whole number. So we'll simply write g must be the square root of 24. And since there are two possible answers, positive and negative, we'll write plus or minus square root 24. So those are what your answers look like. Okay, let's go on to some other problems. With this one, I like to stop and think this way. What happened to m? Okay, well, first it was squared. Second, it was, let me do this. I'm going to write SQR. Second, it was multiplied by 4. And third, we subtracted 18. If you follow the order of operations, that's the order you would do this. If you knew what m was, or you were guessing what m was to try to get 38, you would square it, multiply it, then subtract. So what we're going to do is undo each of these things in reverse order so we can get back to what m is. So how do you undo subtracting 18? You add 18. So we'll get 4m squared equals, let's see, 56. Okay. Now, we've taken care of undid subtracting 18. Let's undo multiplying by 4 by dividing by 4. So divide the left side by 4, you just get m squared. Divide the right side by 4. 56 divided by 4 is 14. Okay. Now, is there a number that squares to get 14? No whole number. So you'll write m equals the square root of 14. And don't forget, there are two possible solutions. Okay. So with this one, the first thing that happened was you added 3. The next thing that happened was you squared, because you do the parentheses first. So we'll undo squaring by square rooting. So if I just square root the left side, I get x plus 3. I don't need the parentheses anymore because it's not being squared anymore. Okay. And when I square root the right side, the square root of 121 is 11. Don't forget, though, there's both positive and negative 11 that work. Okay. Now, how do we undo adding 3? Well, we subtract 3. So you can write positive and negative 11 minus 3. And that'll be easy enough to calculate. Positive 11 minus 3 is 8. Negative 11 minus 3 is negative 14. So you can write your two answers that way. Okay. Let's look at another one. In this one, you subtracted 6, then you squared, then you multiplied by 3. So what we'll do is divide by 3 on both sides. So I get n minus 6. It's still squared, so I need to put parentheses around it and leave the square root sign. Divide by 3, you get 10. Okay. Now, we'll undo squaring next, so we'll square root. And what is the square root of 10? Well, there's no whole number, so we'll write positive and negative square root 10. Okay. Now, how do we undo subtracting 6? You add 6. So we'll write n equals positive and negative square root 10 plus 6. Make sure you're careful that you don't put a plus 6 underneath the square root sign. You get the plus 6 is outside there. Okay? And then I think what I'm going to do, just to make sure this is a little cleaner here, is I'm going to take this one and copy it over here so I got more room to work with it. Okay? So, oh, that should be at x, not a 4 right there. Let's make that x. Maybe I can clean that up a little bit better. There we go. Okay. So now, if I look at what happened to x, you added 7, because it was in the parentheses, then you squared, because you do exponents next, then you multiplied. So we'll start by dividing 7 off of both sides here. Okay. That cancels the 7s. You get x plus 7 squared equals 11. Okay. When you square root to undo the square, you'll just have x plus 7. And then, since there's no whole number that squares to get 11, we'll just write square root 11. And don't forget, there's both a positive and a negative. Okay. Now, how do you undo subtract or adding 7? You'll subtract 7. So we'll just subtract 7 from each side. Here it goes away. Here you get square root 11 minus 7. Okay. So this is what your answer looks like. All right, that should do it.